Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Sum-ren-ku by Morris JB, and here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 such that every digit appears exactly once in each row, column, and box. All purple lines are both region sum lines and Renban lines. What does that mean? Region sum lines are purple lines are divided into segments by box borders, and each segment of a line has the same sum. Different lines may have different segment sums. So, for example, you could have something like, say, 2 and 6 and 3 and 5, and that would be valid. Because 2 and 6 add up to 8, 3 and 5 add up to 8. The box borders divides the line into the segments 2 and 6 and 3 and 5, and therefore they sum up to the same sum. However, this doesn't work because of the Renban line restrictions, which all purple lines are also, where digits on a purple Renban line form a consecutive set of digits in any order. Obviously, 2, 3, 5, 6 does not form a set of consecutive digits. And that's consecutive. You cannot have repeats also on Renban lines, normally. There are some Renban plus lines which you have that you don't have that restriction, but those are fairly rare. Those are actually probably extremely rare. But 2, 3, 5, 6 doesn't form a set of consecutive digits. However, you could have something like 2, 5, 3, 4, and that would satisfy both the region sum line and the Renban line. So that's an example of how the purple lines could work. And finally, we have Kropki dots, where cells separated by a white dot must be sequential, and not all white dots are given. So, for example, say this was a 6, then this would have to be 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have 5 digits here and here, which must be a Renban. And they break into sets of 3 digits and 2 digits, all of which add up to the same sum. That means they must add up to an even sum for the sum of those 5 digits. Well, you cannot have 1 through 5, because that adds up to 15, which is odd. You could have 2 through 6. Yeah, you could have 2 through 6, no 3 through 7, because that adds up to 25. 4 through 8 works, so you could have 2 through 6 or 4 through 8. On this region Sum-ren-ku line, I guess. Maybe we should call it that. 2 through 6 works, 4 through 8 works, 3 through 7 does not, 5 through 9 does not, because that adds up to 35. Okay. 4 digits are not as restrictive, because 4 digits, so we have that information. These are 1, 2, 3, 4, 5, 6, 7, 8, 9 in length for here. And I think this is also 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 in length. And this goes through 1, 2, 3, 4, 5 regions. So that means it's the sum of the digits 1 through 9, which is 45, divided by 5 is 9. So this is 9. I think this is the same, right? 1, 2, 1, 2, 3, 4, 5 regions. So this is 9 also. These digits are consecutive and are 2 unique digits, adding up to 9. So it has to be 4 and 5 here as a pair. We know 1 and 9 cannot appear here. We do know also this is 2 through 6 or 4 through 8. So we're guaranteed 4, 5, and 6 here, which means the remaining digits in column 9 are 1, 2, 3, 7, 8, 9. Obviously, 9 can't be here because of 9 in the row. Remaining digits here have to be 1, 8, 2, 7, or 3, 6. To add up to 9. So is this. This can't be 4, 5 because of 4, 5 pair in the box. Well, 9 can't be here. 9 could be here. Or 9 cannot be here. Hmm. Okay. Oof. Okay, let's just mark these 2 through 8. So this is also 2 through 8. Hmm. Okay. So 2 through 6 means this must be 4 and 6 here. Right? So then this would have... Okay, so then... Okay, yeah, let's mark these as what they could be. And 2 through 5, which adds up to 10. Or you have 4 through 8. 4 through 8 adds up to... You have 12, 12, and 6. So that would be 4, 5, and 6, and 7, 8. So this is either 4, 6. This is 2, 3, 5. Or this is 7, 8, and this is 4, 5, 6. Yes. So you're guaranteed 5 here. You're not guaranteed anything else here. This is 4, 6, or 7, 8. Oh, interesting. And this is 2, 3, 4, 5, 6 with 5 guaranteed here. So if this were 7, 8, that would force this to be 3, 6. If this is 4, 6, obviously you can't have a 6 remaining in the box. So you're guaranteed 6 in one of these 4 cells. That doesn't really help us much, but okay. We're guaranteed a 5 here. So if you have 4 digits, basically you just have 2 of the outside ones in one set. It could be any set of 4 digits, unfortunately, so that's not that restrictive. Okay. What else do we have? Hmm. Oh. Okay. Well, never mind. I was thinking that this has to be a certain way, but yeah, it's not what I was thinking of. So these are all consecutive as pairs. Oh, that's interesting. So I don't think this can ever be 4, 5. And I don't think this could be 4, 5 either. Right? If this is 4, 5, that means they must be consecutive with 3 and 6. And then this would have to be, well, you'd have to have, yeah, it just doesn't work. Right? You'd have 4, 5 consecutive with 3 and 6. Well, we know that this can't be 4, 5. If this is 4, 5, that's consecutive with 3 and 6. That would leave that as 2, and then we'd have 7, 8, 9, and 1 remaining here, which is not possible. So this has to be 1, 8, 2, 7, 3, 6, maybe. Can this be 4, 5? I don't think so. Right? Because... So either this is... Okay, that's interesting. Either this is 9. So where is the 9 in row 8? I guess I should say. 9 cannot be here because it must add up to 9 on this Sum-ren-ku line. 9 cannot be here because of 9 in the box, so 9 has to be either here, which means this is 8. This would be then 1 and 2 adding up. And then that could form... So this would be 1 and 2. So this would have to be 7 through 4 here to add up to be a renban, I should say. Or we have a 9 here, which forces this to be 6, 7, 8, 9. So then this would be 6 and 9, and this would be 7 and 8. Either way, we are guaranteed 6 or 7 here. Right? So say we had 9, 8, 7, 6. Oh, that doesn't work. Because, yeah, if we had 9, 8, 7, 6 here, that would force this to be a 4, 5 pair to add up to 9. But then this would be 3 and 6 as a pair. And the 6 would be duplicated in this row. So this cannot be 9 here. Therefore, 9 must be here, which makes this 8 and 1. That's consecutive with 2 and 7. So this cannot be 1, 2, 7, or 8. It's 3, 6 as a pair. This eliminates 2, 3, and 6 there. So this is 4 and 5. Well, we have as this renban here. Well, this eliminates 1 through 8. 1, 2, 3, 6, 7, 8 in this Sum-ren-ku line. So this must be 4, 5 as a pair, which eliminates 4, 6 as a possibility here. So this is 7, 8, 4, 5, and 6 there. That eliminates 3, 6 from this cell. This has to be 4, 5, 6, 7, because we need a 7 on this Sum-ren-ku line. And this can't be 3. This has to be not 2, 4, 5, or 6, so it's 3, which makes this a 2, 3, 5 to add up with 4 and 6 here. These are consecutive, so, well, we don't know which one that is. But we have a 4, 5 pair in row 5, which eliminates 4, 5 in the rest of the row, so this can't be 4, 5, it's 6, which makes that 4. This can no longer be 3 or 6. 6 eliminates 6 here, so that's 3, which is consecutive with 4, so that's 5. That's 4 and 5 there. 3 eliminates 3 here, so it's 6. 6 eliminates 6 here. This has to be 7 and 4, adding up to 5 and 6 here. because 11, and we have 11 on each side. So this must be 5, that's 6. Okay. Where are 3 and 6 in on this Sum-ren-ku line? It has to be here. So this cannot be 2, 3. It's 1, 7, 8, 9. No 3, 6 here. No, this is 3 or 6 here. Sorry. Remaining digits of... Let's do column 3. We have 2, 3, and 6. Okay. Remaining, this can't be 6 because of 6 in the row. So 6 has to be one of these two. Remaining digits of column 4. We have 1, 8, and 9. Okay. Huh. Okay. This cannot contain 4, 5, and 6. This can't contain 6. Oh, there we go. So this, since this can't contain 4, 5, and 6, and this can't contain 6, this can never contain a 6 here. So it has to be 7, 8. It cannot be 6, 7, 8, and 9. It can't be 5, 6, 7, 8. No 4, 5, 6, 7. No 3 through 6. It has to be either 2 through 5 or 1 through 4. So 2 through 5 or 1 through 4. There's no 4, 5 here. So this has to be 2 and 3 here. And this must be 1 and 4. To add up to... That eliminates 1 here in the rest of the row. That eliminates 2, 7 as a pair here. This is 1, 8, which eliminates 8 in the rest of the box. So this is 9. Actually, I don't know if I said it correctly. Anyways, this leaves a 7 here. 7 eliminates 7 here, so it's 8 and 7. 8 eliminates 8 here, so it's 1 and 8. This cannot be 1 or 8 because of the 1, 8 on the line already, so this is 2 and 7. 1, 4 as a pair eliminates 1 and 4 in the rest of the box, so this is 7, 8, and 9. This is 2, 5 as a pair, which eliminates 2, 5 in the rest of the rows, so that's 4 and 5. The 7, 8, 9 triplet eliminates 7, 8, and 9 in the rest of the column, so this is 1. Um, 9 here eliminates 9 here and 9 here. Can this ever be 8? If it's 8, it has to add up to, well, 6 and 9. It has to be either 8, 5, adding up to 6, 7, or 8, 7, adding up to 6, 9. And neither of those work, because this can't be 8 and 5 because of 5 in the box. This can't be 8 and 7 because of 7 in the box. So this must be 1, which must be with 4 to add up to 5, and that makes this 2, 3 as a pair. So this cannot be 6. This is 2, 3 as a pair. This 1, 2, 3, 4 triplet eliminates 1 through 4 in the rest of the rows. This can't be 2. It's 5. That's 2. This has to be 6 because that's the only place remaining in the column for 6. 8 eliminates 8 here, so it's 7. This can't be 7 or 8. It's 9, which makes that an 8. 1 eliminates 1 here, so that's 8. I guess we could have gotten that from that earlier. Anyways, 2, 7 as a pair eliminates 2 and 7 in the rest of the column. This can't be 2. It's 5, which makes that 2. It also eliminates 7 here, so it's 4, which makes that 7. 4 eliminates 4 here, so it's 1, which makes that 4. And the rest we have to do from normal Sudoku. Okay. Remaining digits in row 1. We have 5 and 6. Remaining digits in row 2. We have 2 and 4. Remaining digits in row 3. We have 1 and 3. Next set. Remaining digits of box 9 are 1, 6, and 8. 1 cannot be either of these cells, so 1 has to be here. And this becomes a 6, 8 pair. Remaining digits of row 9 then are 7 and 9. 9 cannot be here because of 9 in the box, so that's 7. This is 9. Remaining digits of box 8. We have 3 and 8. 8 cannot be here because of 8 in the column, so that's 3. This is 8, which leaves remaining digits here as 4 and 5. 3 here eliminates 3 in the column, so this is 2 and 3. That leaves us as 7 in column 6. 7 eliminates 7 here, so it's 2 and 7. 2 eliminates 2 here, so it's 3, which makes this 2, which makes that 3. That makes that 1 and 3. Remaining digits of column 5 are 1, 2, and 9. Okay, it's still pretty broad. No 1 here, no 2 here because of the respective 1 and 2s in the rows. We have, in column 7, 3, 6, and 8 remaining, but this cannot be 8 because of 8 in the row, so that's 3 and 6, which makes this a 3, 6 pair, which eliminates 3 and 6 in the rest. Oh, this 6 eliminates 6 here. So that's 3, which makes this 6, which makes that 3. 6 here eliminates 6 here, so that's 8 and 6. Remaining digits in column 8 are 5, 8, and 9. No 5 or 8 here, so this must be 9. No 5 or 9 here, so this must be 8, which makes this 5. Excuse me. 9 eliminates 9 here, so that's 2. No 2 here. Remaining digits of row 4 are 6 and 7. And this can't be 7 because of 7 in the column. So this is 6, that's 7, which eliminates 6 here. So it's 5 and 6, which eliminates 5 here. So it's 4 and 5, which eliminates 4 here. So that's 2 and 4. That leaves this. We have 2 can't be here, so 2 has to be here. This is 1 or 9, but cannot be 9 because of 9 in the column. So that's 1 and not, I don't know how I did that. 9 there, so that's 1, which makes this 8 here and 9 here. Congratulations! Hopefully you enjoyed the puzzle. I would like to give a special thanks to Nico D for helping test and modify this puzzle. Interesting section. It is interesting. Like there's some certain assumptions that come with these. So it was kind of interesting to see how that actually worked. Kind of restricted, though. The Sum-ren-ku rule set is pretty restrictive. So, yeah, I don't know how many future puzzles would have something similar to these. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.